It's chemistry and you are watching Chem Science.
In this video, we'll solve A-level chemistry question paper 5-2 of the examination series Feb-March 2022, and we'll be discussing question 2 as in our earlier video we have already discussed question 1. And along with this paper solving, we'll also see how to find out the variables, what are the measurements which we should consider while writing a paper, what are errors and accuracies, and how to calculate the percentage error. So here we start with question 2 of this paper. The conductivity of an ionic solution can be determined by passing an electric current through the solution and measuring the conductivity using the conductivity meter. A student carries out an experiment to measure the conductivity of different solutions of ethanoic acid, which is a weak acid. The acid dissociation constant Ka can be determined from this experiment. Now the student makes a standard solution A of 250 cm³ of 2 mole per dm³ ethanoic acid. State what is meant by a standard solution. Now here they have said a standard solution of A is prepared, and about A the information is given. What do you mean by the standard solution? Now standard solution is any solution whose concentration is known, or a solution of known concentration. That's the answer. If we know the concentration of the solution and we are using it, we can say it's a standard solution. Next question says describe how the student should make a standard solution A from pure ethanoic acid. The concentration of standard solution A should be 2 mole per dm³ to the nearest 3 significant figures. Your answer should state the name and the capacity of any apparatus that the student should use. A balance is not available. Pure ethanoic acid is a liquid with a density of 1.05 gram per centimeter cube at a room temperature. You may wish to write your answer using a series of numbered steps, and here they have given the molecular mass of ethanoic acid, which is 60. Now you can always pause the video and reread the question to understand what exactly is asked. Here we are asked to make a 2 mole per dm³ centimeter³ concentration of our ethanoic acid, and the density of ethanoic acid is given, which is 1.05 gram per centimeter cube. Now if this is gram per centimeter cube, we want to convert that concentration in mole per dm³. We are going to change grams into moles and centimeter cube into dm³, and for that what are we going to do is that the concentration of our acid solution, what we are going to do is 1.05, that's the mass. We are going to divide that by the molecular mass of ethanoic acid, that is 60, because mass divided by moles gives us the mass divided by molecular mass gives us the moles, and if we want to change per centimeter cube into dm³, we have to multiply it by 1000. So our answer is 17.5 moles per dm³. Now this is the answer, and you can say this is the concentration of a pure liquid solution. Now if we want to take a concentration of 2 moles per dm³, this is what we are going to make, 2 moles per dm³, and if we want to say suppose make it into 250 centimeter cube of a solution, then what are we going to do is that multiply 2 into 250, because we want 2 moles per dm³ into 250 centimeter cube of solution, and we are going to divide that by the density, that is moles per dm³, 17.5. Now that is going to give us the answer as 28.55. This is the answer. So 28.55 centimeter cube, if we'll take into 250 centimeter cube volumetric flask, we'll get the concentration of A with 2 moles per dm³. So now what are the steps which we are going to write? Use burette to pour, use burette to transfer, use burette to transfer 28.55 centimeter cube of ethanoic acid in 250 centimeter cube volumetric flask and next step is add distilled water. Now I would always prefer that specify distilled water, don't just mention water, because here it makes the difference. If we want to make a pure solution, then we need to use distilled water. So specify distilled water. Add distilled water to the flask till mark there is a mark in the volumetric flask. Till that mark we need to fill up with the distilled water after taking 28.55 centimeter cube of ethanoic acid in a liquid form and shake well. That is the main process which we are going to do, and shake well. This is how we make the solution. What we did, you can see again, what we did is change the density of grams per centimeter cube into moles per dm cube. So we got 17.5 moles per dm cube. Now suppose if we want to make that solution into 250 centimeter cube, then if we take 17.5 moles per dm cube into 250 centimeter cube directly, but then we don't want this concentration, we want 2 moles per dm cube. So then in what volume we will use? So if we cross multiply, then we get this 2 multiplied by 250. That's what we have done here. 2 multiplied by 250 divided by 17.5, and that gave us the answer 28.55 centimeter cube. Now that is the volume of the solution. Liquid ethanoic acid will be used to make the concentration of our concentration in 250 volumetric flask. This is how we are going to calculate by cross multiplication if we are confused. The next sub question here is that the student wears chemically resistant gloves throughout this procedure. Suggest why. Because it's a weak, though it's a weak acid, it's an acid. So we can say that ethanoic acid is corrosive. Ethanoic acid, most of the acids are corrosive. So ethanoic acid is corrosive in its pure form. So we need to use the chemically resistant gloves. Let's go ahead with the next part. The next part says the student dilutes the standard solution A with distilled water to make solutions of different concentration. The conductivity of these solutions is measured. The table shows the result. Now what are we supposed to find out is calculate the column 3 and column 4. Now column 3 and column 4, what is given in the column 1? It's the concentration of ethanoic acid given in moles per dm cube, and we need to find out 1 divided by root of the concentration of ethanoic acid, which we can easily do in the calculator, and here it's given the conductivity. Now we are supposed to change the molar conductivity. Now what we are going to do here is to find the value in column 4, we are going to divide the values of these two columns, that is column 2 divided by column 1. That will give us the answer here. So you can pause the video and I'll give you the values of these two columns. So here are the two columns with the correct values, and you can note down here that I've written all the values in 3 significant figures in each column, in both the column. So here are our answers. Let's go ahead. What is written here is that in order to determine Ka, the results must be used to obtain 2 sets of data. Column 3 is a reciprocal of the square root of concentration, and column 4 is a molar conductivity, which is found by dividing the conductivity column 2 by the concentration. So that's what we have already done. Complete column 3 and 4, give all the values in 3 significant figures. Identify the dependent variable in this experiment. Now what is dependent variable is what we measure. Dependent variable is what we measure. What is independent variable? Independent variable is a one which we change. Now what are we changing here? So in concentration. So independent variable is concentration of ethanoic acid, and dependent variable is the conductivity here, because by changing the concentration we are measuring the conductivity. So remember here, whatever we change is the independent variable and whatever we measure is the dependent variable. So here we are measuring conductivity, and so conductivity is the dependent variable. The next sub question says that the student decided to measure the conductivity of distilled water at the start of the experiment. Suggest why. Now this is because we want to find out the conductivity of distilled water, that is without ethanoic acid, and this is generally done to calibrate our instruments. So this is done to calibrate the conductivity meter. Generally a blank reading is done to calibrate the instrument. So here our conductivity meter is the instrument. To calibrate it, we are finding the conductivity of distilled water. Next is state one variable that should be controlled. Now what are we going to keep same? The factor which we keep same during the experiment, and one of the important thing is the temperature, because temperature is going to change the conductivity. So we cannot change the temperature throughout the experiment. So temperature is kept constant throughout the experiment, and that is called the controlled variable. The next part says plot a graph on the grid to show the relationship between molar conductivity delta M and the reciprocal of the square root of ethanoic acid, which we have already found out in column 3. Use a cross to plot each data point. Draw a line of best fit that includes the origin. Now here you are told to include the origin, so we are supposed to do that. Now I'll minimize the grid and I'll draw a graph for you so that you can find out how to draw the line of best fit. So here is the grid which I have minimized for you, and I have plotted the graph of all the points of column 3 and 4 with a cross. Now let's draw a line of best fit. So here is the line of best fit passing from the origin. So you can see here is a line passing from the origin, and you can also see that there is one point which is anomalous, which is not fit in our line. So that is an anomaly point. And let's go ahead and read the next part of the question. The next part of the question says circle one point on the graph that you consider to be most anomalous. Now that we have already done. The conductivity meter was correctly functioning. Suggest one reason why this anomaly may have occurred during this experimental procedure. Now if the conductivity meter is working properly and one of the point only has gone out, and that we can see that it is much higher. We can see here above that the point is higher, means the conductivity is much more than what it was required. Now that shows that if conductivity is more, the concentration of the solution is not made correctly. So what you can either write is that the concentration of the solution is not made correctly, or you can say the dilution of the acid is not done correctly. So concentration of acid is not made or prepared correctly. Now that is the answer. Or you can see the dilution of the solution is not done correctly. The next sub question says the equation for the line of best fit is shown, where here the conductivity of molar conductivity of the equation is given here. Use your graph to determine the gradient of the line of best fit. State the coordinates of both points you used in your calculation, and this must be selected from your line of best fit. Give the gradient to 3 significant figures. Now I'll go back to the graph and take any 2 coordinates to find out the gradient. You can choose the coordinates of any of your choice. That's not going to make a difference. So I'm going back to the graph and finding out my own coordinates. Now looking at the graph, I feel that the point 3rd and the point 6th, these are the 2 points which are fitting my line exactly. So I'll take the coordinates of these 2 points, that is the 3rd point and the 6th point. So the coordinates for the 3rd point was 8.94 and y-axis is 0.154. Now the 5th point coordinates were, 6th point coordinates were 25.3 on x-axis and 0.428 on y-axis, and we need to find out the gradient for these points. Now gradient for these points is, as what I understand, is y2 minus y1 upon x2 minus x1. So here we have 0.428 minus 0.154 divide by, we have 25.3 minus 8.94, and this gives us the answer as 0.0167. Now this is the gradient, so here we write as 0.0167, that's a gradient. The next part of the same question here is that determine the acid dissociation constant Ka of ethanoic acid, include units in your answer. Now how to find the Ka? Let's go here and look at the equation here. Now if we rearrange this equation, we have the molar conductivity multiplied by the root of concentration of ethanoic acid, that's how we are going to write it, divide by the standard molarity. Okay, now this is the answer, and this gives us the root of K. Now if we want to remove out the root of K, we need to square the other side, and that will give us the value of K. Now if we want to substitute the gradient here, now if we are substituting the gradient here, then we have this portion as our gradient. So if we substitute the gradient here, because our gradient is the ratio of the molar conductivity divided by 1 upon root of the concentration of acid. So if we substitute this value, the numerator is our gradient. So substituting gradient here, divide by the standard molarity, that is 3.91, and the square of the whole value will give us the value of Ka. So if we substitute the gradient here, which is 0.0167, so substituting Ka is equal to the gradient 0.0167 divided by the standard conductivity 3.91 and the square of the whole value, that will give us the value of Ka, and this gives us the value of 1.82 into 10 power minus 5. Now that's the value of Ka what we have received from here about our gradient and the equations which was given to us. So 1.82 into 10 power minus 5 is our Ka value, and always the unit of K is moles per dm cube, especially when we have look up at above our equation and calculate the value of K. That's what we are getting, moles per dm cube. The next part of the question here is, the student repeats the experiment with propanoic acid. The numerical value of Ka of propanoic acid is experimentally determined as 1.28 into 10 power minus 5. The theoretical value is 1.34 into 10 power minus 5. Comment on the validity of the experiment results. Assume the maximum total percentage error from the results made in is 6.5%. Now let's understand what about this maximum percentage error. Now if the maximum percentage error is greater our value from the experiment is less valid. What we'll say is less valid. So if we have these values, this is the theoretical value and 1.28 into 10 power minus 5 is the experimental value. So let's calculate the percentage error of our values. So if we want to find out the percentage error, then what are we going to do is subtract both the values, that is 1.34 into 10 power minus 5 minus 1.28 into 10 power minus 5, and we are going to divide this by our actual theoretical value. Theoretical value is 1.34 into 10 power minus 5, and we'll multiply that by the 100. Now if we do this calculation, we get as percentage error is 4.5%. Now if this is 4.5%, this is our percentage error is lesser than the maximum percentage error, which is 6.5 given in the value given in the question. So let me rewrite this value on one side and write the answer here. That is 4.5% here, and I'll say that the value is valid. The experiment is valid because the percentage error, I'm writing in short because I'm in short of lines, but you can minimize it or calculate the percentage error in just one line and explain it properly. The percentage error calculated is less than the maximum total percentage error. That is the reason that the experimental values calculated here is valid. Okay, and this is how we have finished the solving of Feb March series 2022 question paper 5-2, and I hope this is going to give a valuable examination tips to write paper 5. So what we have discussed here is that how to make the solution. Making solution is very important because every time in all the paper 5 is asked. So what you need to learn is how to make the solution, calculate the percentage error, how to make the measurements, that also you should know, because in making the solutions we have found out that we made a solution of 250 centimeter cube. Now so you need to understand how are you going to make the measurements, calculate, use burette and pipette, use volumetric flask to make all these measurements. Also you should know that what are the factors, that is what are the variables. So what is an independent variable, what is dependent variable, what are controlled variables, all these are the important points you should know. We also have found out that how to plot a graph and calculate the gradient, plot a graph and gradient, that's what we have done. Also understand how are we going to substitute this gradient into an equation for the further calculation. That is most important part, that how to use the gradient, how to substitute the gradient in given equation and calculate the value asked in the question. So these are the important points which we have understood while solving this paper question 5-2.